Hi everyone, I'm Cheryl. In this problem, we're asked to find the limit as xy approaches 1, -3 of a function y and show that it equals -3. To do this, we're going to use the definition of a limit. And the definition of a limit states that if you have a function of two variables, which is what we're dealing with, and it's defined everywhere except possibly at a given point x0, y0, on an open disk centered at x0, y0. And then we're going to let L be a real number. What happens is that the limit as xy approaches x0, y0 of my function equals L if for every epsilon greater than 0, we can find a delta greater than 0, such that this absolute value, which is f of xy minus L, think of this as the distance between my function and its limit, is less than epsilon. And that happens whenever we have this square root being between 0 and delta. Well, what is this square root? Well, if you think about it, it's really the distance between any point xy and the point x0, y0. When the distance between those 2 points is always less than a constant, think of it as being a circle, and all of the points are inside of that circle that has radius delta. Let's take a look at the picture of that to get a better idea of what's going on. So here I have my function f. It's a function of two variables, so it's a surface in space. And here's my point x0, y0. Okay? Well, if I go up to my function, I don't have to have the function defined at this point. So there might be a hole in the surface at that point, or maybe it's going to infinity. But near the point x0, y0, I know my function is defined, and I'll be able to find a limit. So the limit looks like it's approaching this value. So what I'm doing is I want to be able to choose any epsilon I want. Epsilon is going to be a tolerance around the number L. So if I move a little bit higher than L and a little bit lower than L, so this will be L plus epsilon, and this will be L minus epsilon. No matter what I choose, I will be able to find a delta that describes the radius of a circle so that if I pick any point in that circle and I move up to my surface and across, the answer is going to be within those tolerances. So everything between L plus epsilon and L minus epsilon. And the interesting thing is that epsilon should be or can be anything. So I can make that tolerance around L very, very tiny, which means there's going to be a corresponding delta. And many times it's a very small circle around this point. But I'm still guaranteed that all of my function values will be between L plus epsilon and L minus epsilon. All right, well, that's kind of an overview of how it works in general. Let's take a look at our specific problem. In our specific problem, I'm having the limit as xy approaches 1, -3. So my x0, y0 for this problem is the point 1, -3. The function that I'm trying to take the limit of is the function y. So my function f of xy is simply y. And in this case, my limit, I'm hoping to show that that equals -3. Okay, so what do I need to do? First of all, let's take a look at our definition. Our function f has to be a function of two variables that's defined everywhere except possibly at 1, -3. Well, y is a plane, and y is a plane that is parallel to the xz plane. So it's certainly defined everywhere, even at the point 1, -3. So the first part of my definition does hold. So what I want to show then is I want to show that for every epsilon greater than 0, there exists a delta greater than 0, such that the absolute value of y minus a negative 3 is less than epsilon whenever the square root of x minus 1 quantity squared plus y minus a negative 3 quantity squared is less than delta. Okay, so what happens here is this is the statement that I want to prove. This is the statement that I am allowed to assume. Okay? So I need to be able to show this based on this statement. Now, the tricky thing is, going from one statement to the other, I need to find a connection between these two. So what I want to do is I want to be able to find a way of writing delta in terms of epsilon so I can connect the two together. All right? So in order to do that, I need to do a little bit of background work. So for my background work, I'm going to start with the absolute value of y minus a negative 3. And I know that is the absolute value of y plus 3. Okay? And I also know that this is the same thing as the square root of y plus 3 quantity squared. And I know that this is less than or equal to the square root of x minus 1 quantity squared plus y plus 3 quantity squared. Now, why do I know that? Well, I know that x minus 1 quantity squared is a positive number or possibly 0. So the smallest this thing could be would be 0. So that means that this overall expression is going to be larger than the one above it. And take a look at what this thing is. Okay? This thing I know is less than delta. That's what I'm allowed to assume. So if I want the absolute value of x plus 3 to be less than epsilon, then I'm going to choose delta and epsilon to be the same thing. So again, in my picture here, whatever epsilon they give me, that's exactly the same thing that I'm going to choose for the radius of my circle. Okay, now, to be honest, that was just background. I really have to prove the statement. I have to prove that the absolute value of x plus 3 is less than epsilon. So we want to prove my statement. And to do this, I'm going to start out by saying we'll say for any epsilon greater than 0, I'm going to let delta equal epsilon. And I'm also going to know that we're going to assume that the square root of x minus 1 quantity squared plus y plus 3 quantity squared is less than delta. So I'll begin with the absolute value of y minus a negative 3. Now remember, this is what, again, I said this before, this is the statement I want to prove. So I want to get from here to epsilon. Okay. So this is the absolute value of y plus 3. This algebra part's going to look very familiar to my background work. This is equal to the square root of y plus 3 quantity squared, which is less than or equal to the square root of x minus 1 quantity squared plus y plus 3 quantity squared. And this statement is less than delta. And because we said that delta and epsilon were going to be the same thing, this is equal to epsilon. And now I've shown that the absolute value of y plus 3 is less than epsilon. And that's what was required to prove this limit. I hope that was helpful. Thanks.